All right, we are going to look at a static equilibrium problem. This is all about Newton's first law, meaning the sum of my forces equals 0. Now, to be specific, when we add up our forces, we're going to think about them in components. So the sum of the forces in the x direction is 0, and the sum of the forces in the y direction is 0. All right, so I have a 10 Newton object supported by 2 strings. They're massless strings in all intensive purposes. We can neglect their mass. And one's at an angle of 30 degrees, the other one's at an angle of 45 degrees. Now, whenever you have a situation like this, you can look at those two, and the one that is more vertical is going to be the one that is a larger tension because it's supporting more of the weight because it's more vertical. So if you ever run into a conceptual question with that, that's kind of a quick answer. All right, now let's go ahead and just solve for them because that would be the other way we could figure out which one was larger. All right. So the first step is we talk about this as a Newton's second law problem, so we need to identify that the sum of the forces in the x direction equals 0 and the sum of the forces in the y direction equals 0. All right. So let's find the x and y components of all the forces acting in this box. So tension 1 is acting up and to the right, so it will have a x component of T1 cosine 45 and a y component of T1 sine 45. T2 is acting to the left and up. Now that left, when we add up this component, it's going to have a negative sign in our force equation because it's in the negative direction. That's what this arrow tells me. So this is T2 cosine of 30. This one is T2 sine of 30. And then last but not least, the force that's always there for us, gravity, mg. Now, sometimes they'll give you a weight, which is in newtons, so this gave me 10 newtons. That's what m and g combined is. Sometimes they'll give you a mass, maybe 10 kilograms. And in that case, you'll have to do 10 times 9.8. So depending on what you're given, mass or weight, you may have to multiply by g, or it may already have been multiplied by g. So in this case, my mg is 10 newtons. All right, let's add these up in our equation. So in the x direction, I have these two, T1 and T2. Sometimes people like to redraw this to make it a little more obvious what's all going on, because when we resolve this T1 into these components, we essentially no longer have that T1. And same thing for the T2. So when we redraw this, I'll have that T1 cosine of 45 and the T1 sine of 45. On the other side, I have T2 sine of 30 and T2 cosine of 30. And then I have my 10 newtons down. Sometimes this helps students kind of identify that, okay, left and right is x, up and down is y. It kind of maybe takes the problem that started and that free body diagram you first drew and kind of simplifies it a little bit. All right, so in our x direction, we have these two. In our y direction, we have these 3. Okay. All right, so in our x, I have T1 cosine 45 minus T2 sine, cosine 30 equals 0. Notice the minus sign here. It's addition, but this one is to the left. So maybe if you wanted to say this was plus a negative T2, to kind of help you remind yourself that we're adding vectors, but this one just has a negative direction. All right. In the y direction, I have T2 sine of 30 plus T1 sine of 45 plus a negative 10 equals 0. At this point, I have two equations with two unknowns. All right. Here, we're going to solve the algebra. But if you want to see using the matrix solver on your calculator, which we use the Polysimul Pro app, by all means, use the link below. All right, so when we solve a system of equations, we're going to solve for one variable and substitute into the other. So we pick an equation that looks easier to solve. So I'm going to go with the x direction here. So I have T1 cosine 45, and I'm going to move this T2 cosine over to the other side. T2 cosine of 30. Solve for T1, so I'm going to divide the cosine over. So I have T1 is equal to T2 times the cosine of 30 divided by the cosine of 45. I'm now going to substitute this in wherever I have a T1 in my other equation. So now I have T2 sine of 30 plus T2 cosine 30, all divided by the cosine of 45. Now this right here was just this T1 term. Okay. Don't forget you need that sine of 45 on there, times the sine of 45. And I'm going to move this 10 over to the other side, so I get 10 there. At this point, I have all my T2s on one side. I'm just going to factor out a T2. So I have T2 times the sine of 30 plus, look at this, sine of 45 divided by cosine of 45. That is tangent. So now I have cosine of 30 times the tangent of 45 equals 10. And so then I can divide this whole mess in the parentheses over to the other side. So I have T2 is equal to 10 divided by the sine of 30 plus the cosine of 30 times the tangent of 45. For those of you that know your unit circle pretty well, the sine of 30 and the tangent of 45 should pop out as pretty easy to change. When you plug this in your calculator, you should get 7.3 newtons. If you don't get 7.3 newtons, make sure your mode is in degrees. Once we have the 7.3 newtons, we can plug that back into our first equation, and we get a T1 value of 9.0 newtons. And again, if you want to see using the matrix solver, by all means, go to the matrix solving link below.